Alright, so see how this goes. Label one interior, one exterior, one central angle. If you start with the interior, go to any of the corners. Just make an arc and put a capital I there. That's indicating an interior angle. You get one mark already. An exterior, pick any corner again, right? I'm going to pick this one perhaps. You pick one of the sides and just travel along it and just keep going, right? That would be an exterior angle there, right? If you wanted to do another one, there's another exterior, but you just need one labeled there. And then one one central as well. So you go to the center, pick any of the sides, and just make sure there's just one slice in there, meaning one side is across here. So that angle right there is a central angle. So you've labeled one of each. If you did that correctly, you get 3 marks for that. The sum of interior angles of this particular polygon, I want you to use your formula sheet. You're going to get this one at the back of your exam booklet. And so, right, sum of interior angles of a polygon, it actually describes what every formula does. That's what we call S. That's the one you want to use. And N is the number of sides. Now, I hope this is a slam dunk. Okay, I hope this is like, I got it. But you got to make sure you count correctly. So I put a check mark where I start counting with this side. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I count 13 sides. And so that's what we're going to use for all of the formulas. So it calls for 13 minus 2 times 180. That ends up being 11 times 180. And if you multiply that, you get 1,980 degrees. Okay, so you got to make sure on the exam you put degrees on there to get the full marks. Calculate the measure of just one interior angle. Keep in mind there are 13 interior angles. And so when you calculated this, you're calculating what all 13 add up to. Okay? So if you just want one interior angle, you could use this formula, right? Measure of one interior angle, that is this formula right here, which is really take the sum, right, the same part there, and divide it by the number of sides. So I'm going to repeat the process just in case, because usually the province just asks you for one of these. They won't do all 5, right? They could do 2, but more than that, it's not going to happen, right? So I already know the top part. I'm just going to say this is 1980, and I divide it by 13. And make sure you round to 2 decimals no matter what. Okay? And that gives you 152.31 degrees if you round that correctly. I actually encourage you to always circle your final answer. Circle your final answer, then we know for sure you're not going to lose any marks there if there are a bunch of things happening. So every single one of these eyes measures 152.31. Okay. Calculate the measure of just one exterior angle. That is 360 divided by n. So it's just 360 divided by 13. And that gives you 27.69 degrees. Or if you have the interior angle, you could just go 180 minus this angle right there. If I'd say stick with the formula, but if this ever becomes an issue where they don't tell you the number of sides, listen carefully. What if they just say, hey, there's this polygon that has the interior angle of this, right? What is the exterior angle? Then this would be the go-to there. I haven't seen it yet. But you know, you never know. That's what I'm going to say. Central angle is the same in terms of its measurement. It's just located in a different place. So it's 360 divided by 13. You get the exact same answer as the exterior angle. Okay. This one is quite popular. Calculate the number of diagonals. It will say calculate or draw the number of diagonals that can be drawn in this thing. I don't know if some of you might wonder, what is a diagonal? It's connecting corners across the shape. That's basically what it is. So right, this corner to that corner, so any corner, any two corners connected across the shape would be considered a diagonal. But you can't double up, you can't count that one. Like from here to here is the same as from here to there, so we just count this as one, okay? So how many can you draw? This formula is extremely important that you get this right. It's divided by 2, okay? It's divided by 2, so keep that in mind. And it's not degrees. This is going to be the number of diagonals. That's the one that is not degrees. So it's 13 times 13 minus 3 divided by 2. Take your time, clean it up, okay? And so when you multiply 13 times 10 and then divide it by 2, you get 65 diagonals. Oops, sorry, you can't see that. There it is. 65 diagonals. Okay. What's the sum of all exterior angles? Do you know that one? All exterior angles always add up to? If I give you a choice, 180 or 360, which one would you pick?
360.
It's always 360, okay? Sometimes just coming up with one example is all you need. Like if you had a rectangle, you know all of them are 90, okay? And every single one has an exterior angle out here. Every single side is exterior. And exterior, exterior. So guess what? If this is 90, so is that one, right? Every single corner is 90. What's 4 times 90? 360. So maybe sometimes just having one example might help you realize that. Okay, I don't want you to mix this up. The exterior angle of any polygon could be 100 sides. It would always add up to 360. When it comes to quadrilaterals, we know that the interior angles always add up to 360. So don't mix that up. Okay, don't mix that up. Oh, how many points do we have on this page? 3, 4, 5, 6, 7, 8, 9. Yes, got 9 on this page. So you're the teacher today. You decide how much you earned. Backside. This is a backwards example where you find a number of sides, and show work means you cannot guess. You can't just go n is equal to 15. Like, you can't do that. It's not going to be good enough. Okay. So if the sum of interior angles is this, how many sides does it have? We know that the sum, the formula is as follows, right? Okay, we know that that's the case. So I'm just going to plug in S, right? Like, I'm going to plug that in there and then work out what n is. So 3420 is equal to n minus 2 times 180. My go-to here, keep in mind you want n on its own. I first get rid of the 180. So I divide both sides by 180. Okay. That's my first order of business. And that gives me 19 on this side. And on the other side, it turns into 1. Right? So you're just left with n minus 2. That would give you 1 mark already to get to this point. Then you have to go plus 2, plus 2. You're adding here in order to, because minus 2 plus 2 is 0, right? So you're left with n, sorry. And on the other side, it's 21. So this polygon that we're talking about is a 21-sided polygon. A pentagon has the following exterior angles. Determine the value of the last exterior angle. What's a pentagon? N is equal to 5, yes. So how many exterior angles will it have? 5 exterior angles. Okay? It gives you 4. What do they all add up to? 360. So I will go 360 minus 71, minus 68, minus 73, minus 74. I'll just subtract it from 360, and whatever I'm left with is the answer, which is 74 degrees. Just try to, even if you didn't get it today, just write it down. I want you to have these ACs. In fact, if you can have all your ACs, if you can like gather them somehow, it's a good study tool, right, if you go through them. Question, is this a regular polygon, this one right here? Regular polygon needs to have all angles, all interior angles have to be the same, all sides have to be the same. We don't know about the sides, but we know that if the exterior angles are pretty much all over the place, we know the interior angles are going to be different too, right? So this is not regular. Note irregular poly. Okay, it's an irregular polygon because all the angles will be different. All right. Consider the following regular polygon. So you're told this is regular. Okay. It means something to us. It's not just it looks kind of normal, right? That's not what it, like, we have a specific definition for it. Calculate the value of angle C. C is right here, so in a sense we want that angle right there. C is going to be the central angle in this case. And how many sides does this have? 15, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 sides. All right. So we got to go 360 divided by 15, and that gives me 24 degrees even. Okay. So 1 mark for that. Calculate the value of side X. So we want this side right here. This involves trig. If this is 50 feet, that's like from the center to the corner here. What is this side here? You guessed it, it's also going to be 50 feet. And this angle, the 24 you just figured out, is in here. 24 degrees for that angle. What triangle, what scenario do you have here? SAS, right? SAS. Sassy. Okay, so how do you do that? To find x, you go x squared, right? And then it's 50 squared plus 50 squared minus 2 times 50 times 50. That's an isosceles triangle, right? I don't know if you noticed that. Times cosine of 24 degrees. I will explain that you could have used sine law as well later on. I will explain that. But I think cosine law is the quickest here. Please type this in, because when I was marking the last test and there was a trig question, you guys did this very well. You wrote it out, but your answers were kind of off. So I don't know what's happening with your calculators. Maybe you have to make sure it's set to degrees. You cannot see my calculator. Maybe you have to make sure it's set to degrees. Maybe that's number 1 you have to check. Okay? Coming into the exam, you want to make sure you set to degrees. I will remind you the morning of. Okay? So I go 50x squared plus 50x squared minus 2 times 50 times 50 times cosine of 24. I think what some of you are doing is breaking this down. And maybe that's where some of this fell apart. I encourage you, if you have a calculator like me, which most of you have, type it in one shot like that, and then you get your answer there. So that's 432.2727. That keeps going. Use all decimals like that. Then we take the square root, and that's 20.79. And we are in feet, right? So this is going to be feet. The nice thing about the provincial exam, you only lose 1 rounding mark once. So we take off half a mark once, and then you're done. Then you can like mess up on rounding for the rest of the exam. You're not going to lose again, okay? But I'll tell you this, I've marked many exams where you no longer make rounding errors, which would be ideal, right? Because you don't want to lose any marks if possible. What's the perimeter of this polygon? Well, perimeter is a distance around. So you would just take this side that you found here in in B I should say, and you're just gonna go 15 sides times 20.79. Okay, so that gives you 311.85 feet. And listen to this part. If you made a mistake in B, but I see you multiplying your answer by 15, you get the mark here. Okay. All right. Calculate the measure of angle M and N. So M is right here. Remember, it's inside this right triangle. We know it's always 180, right, inside the triangle. So we just go, how about we do the math right here? M is going to be 180 minus the 90 minus 45. So angle M is 45. Yes, this is 45 degrees here. Okay, N, it's also 180 minus, this is a 90 here as well, right? Because it's a straight line here, they add up to 180. If this is 90, this is 90. And we take away the 46. That adds up to 44. Okay, so this is 44 here. And so N is 44 degrees. Make sure you clearly state that here. So you get 1 mark for each. And now your favorite part, the classifying part. So remember, they all have a triangle in front of them. So what's triangle ABD called? ABD, it's this one right here. For sure, yeah. I'm just going to give it a color here. Triangle ABD is a right what? Two angles are the same. Isosceles, yes. Okay. Then we have our ABC. Where's ABC? ABC, it's the big one here. So I'm going to give it a color and just say it's this one right here. What do we know in terms of angles? Maybe you need to do one of these. We know this is 45. We know this at this corner is 46. We could take these two away from 180 and figure out what the top is. That is 89. Or you could have just added 45 and 49. Still, same thing. Same reasoning. Okay. What do we know about the angles? They're all less than 90, correct? Yes. So this is acute. And in terms of side lengths, there are no side lengths, so I don't know. Yes, you do. If they're all different, all sides are going to be this. Yeah, scalene. I should make a song of classifying your triangles. Bring my guitar and just No, I'm quitting your class right now. Okay, BDC. B, D, and C. So connecting those two, those sides there, those points. That would be a right. Scalene as well, right? Because all angles are different. So what do you think of this? I think this is a pretty good exercise on classifying. You got to do a little bit of math and so forth. And then your second favorite, sketching a kite and label 3 properties using appropriate markings. I will allow you to write out as well. If you wrote it out, but make sure you sketch it. What do you think of when you think of a kite? 2 isosceles triangles stacked like this, where one is a little bit smaller than the other. We know this, right? That the sides here are congruent. So that'll be property number 1. You get 1 mark for that. You know that this angle is the same as that angle. Second mark. Third mark may be drawing your diagonals and knowing that they meet at a 90-degree angle. We call that perpendicular. And then the short diagonal here measures the same. It's bisected. So I give you 4 right there. I give you 4. So if you have 3, you're good. If you gave me 1 and then another kite, just to not have too much stuff in there, that's fine. Okay, so this backside is worth 3 and 3 is 6 and 2 is 8, 9. This is 10 and then 2 is 12. 14, 16. Look at that, 16 marks for the backside. Okay, and so 16 and 9 adds up to 25 in total. So we keep the mark that's up on the top here. Doesn't happen very often, does it? All right, so